We'll start by listing the first few elements in each row of our array, and then we'll find a general formula for 2 consecutive elements in that row. Row 1 contains odd numbers. The kth element in row 1 can be expressed as 2k minus 1. The common difference here is 2, so the next term will be 2k plus 1. In the second row, the first element is the sum of 1 and 3. The second element is the sum of 3 and 5, and so forth. The common difference here is 4, so I'll just add 4 to this last term. These are all consecutive multiples of 4. The kth element is 4 times k, and then we'll add 4 to that for the next element in that row. In row 3, the first element is the sum of 4 and 8, 8 and 12, 12 and 16. Our common difference is 8, so I'll add another 8 here. The kth element is going to be the sum of 4k and 4k plus 4. That's 8k plus 4. Since we have a common difference here of 8, this next element is 8k plus 12. In the fourth row, we have 32, 48, 64. I'm going to add these two to get 16k plus 16. Our common difference here is 16, so the next term is 16k plus 32. In the fifth row, here we have 32k plus 48, and this is our sixth row. Let's see if we can find a pattern here. First, I notice that there are a lot of powers of 2 here, so I'm going to rewrite these as powers of 2. For n equals 5, we have 2 to the 5th times k, and then here we have 2 to the 4th times 3. Let's factor out 2 to the 4th, and for n equals 6, we have 2 to the 6th times k plus 2 to the 7th. Let's factor out a power of 2 from each of these. That's 1 less than n, because that's what we have here for n equals 5. So for n equals 4, I'm going to factor out 2 cubed. This gives me 2k plus 2. Over here for n equals 6, I'll factor out 2 to the 5th power. This gives me 2k plus 4. Factoring out 2 squared, I get 2k plus 1. Factoring out 2, I get 2k plus 0. And then factoring out 2 to the 0, I get 2k minus 1. And I think that's our pattern. In row n, the kth element, we take 2 to the power of n minus 1. We have a 2k here, and then we subtract 2 from n to get this constant. We're counting elements that are multiples of 67, so we'll substitute. We're not going to find 67 in this power of 2, so we'll focus on the second factor. The number of elements in the nth row is 51 minus n. So any solution that we have for k has to be less than or equal to 51 minus n. So let's substitute that for this expression here. This expression is going to be less than or equal to 2 times 51 minus n plus n minus 2. Combining like terms, this is 100 minus n, where n is the row number from 1 to 50. This means that our upper bound on 2k plus n minus 2 is 99. Recall that this is our expression that must be a multiple of 67 that's less than or equal to 99. And there's only one solution for that, where 2k plus n minus 2 is equal to 67. And we'll combine like terms. With this expression, multiplying by 2 and substituting down here for 2k should give us our upper bound on n. So from this equation, 69 minus n must be less than or equal to this other expression, 102 minus 2n. And combining like terms, we have that n is less than or equal to 33. So we're looking for multiples of 67 in rows 1 through 33. For example, in the first row, we get 2k is 68 and k is 34. There are 50 numbers in row 1, so we have an entry that is a multiple of 67 in row 1. In row 2, 2k is 67, and k needs to be an integer, so this isn't valid. And from here on out, we're only going to check n that's an odd number. When n is equal to 3, we get another solution. There are 48 elements in the third row, so we found another one. Let's check our upper bound now, 33. This is going to get us 2k equals 36 and k is equal to 18. The number of elements in the 33rd row is 51 minus 33, which is 18. So that's going to be the last element. If we go to the next odd row, we'll have 2k equals 34, k is equal to 17, but there are only 16 elements in that row, so we know we can stop here. We have one valid entry, that's a multiple of 67 per row, with an odd number from 1 to 33. So the number of entries is 17. If you'd like me to solve any other math contest problems, please leave them in the comments.